Well, and nuclear, the most concentrated energy source, is in the nucleus of the atom in fission and fusion. And then fossil energy in the chemical bonds of oil, coal, and gas. And then after that is sunlight. On average, day-night average, representative mid-latitude, solar flux is about 230 watts per square meter. The average wind energy at the surface of the Earth is 2 watts per square meter. Not 200, it's 2. The average geothermal energy is 0.05 watts per square meter at the surface of the Earth. That's about all you need to know, because when you're mining something, if it's more dilute, it's more expensive to mine it, and it's no different in mining energy resources. So, of course, when sunlight is only 200 watts per meter squared, you are mining it over a big area compared to going and digging the concentrated solar energy stored in chemical bonds, which means that it's going to cost more for a while, at least. In fact, if you just take a square meter and say, if I make 10% of the sunlight that hits it converted into energy, in this case electricity, which is not to be confused with energy, since electricity is high-value energy. But let's just take electricity first. If I took 10% of the energy that hit at that representative box in Kansas, and it cost me $300 per square meter of materials plus installation costs, and I got 10% of that, then that defines how much energy I'm going to produce to you. Because over 30 or 40 years, I know I'm going to get 10% of the joules in that area as my product. Now I've told you how much I have to sell you the product for so that I can break even with my materials and installation costs. And if something costs $300 per square meter to make and install, which is a factor of 2 less than what solar panels now cost to make and install, then you have to sell it for 15 or 20 cents a kilowatt hour just to break even. Right? So that's the arithmetic. You can do better, but the real amortization is $1 a watt peak if it were full cost, including installation, which this isn't chart used for, but I use it for that, would translate to fully amortized of about 5 cents a kilowatt hour. So that's the Rosetta Stone of conversion. It may be 6 or 7, it depends on the efficiency, but roughly we'll call it 5. So if you want to make competitive electricity, you have to be on this line somewhere, and solar cells panels are right now on this line. You have to really up their efficiency and or really lower their cost.